Hello Year 10, it's Mrs. Connor here again, you lucky lot. So we finished chapter 20 last week, so we're starting on chapter 21. If you could please rule off where you got to last lesson and put the title and the date, and then just have a quick look at this do now task and see if you can work through it. Please pause the video as you do this. Brilliant, lovely. So if we look at the first one, you may have chosen to draw out the whole sequence of pictures, which is maybe a good idea. You can see you start off with one square here, which is 4 matches. That's here as well. And then to get the next pattern, they've added 3, then they add 3, then they add 3. So if you redraw the picture as it should be, you should then end up with a diagram that looks like this, just with an extra 3 matchsticks on the end. So you've gone from 1 box to 2 boxes to 3 to 4 to 5 boxes. Now the next part says, can you then write a sequence of numbers to show how many matchsticks there are in each pattern of the sequence? Well, you should have had this, because we can see from diagram 1 here there's 4, then we add 3 to get 7, then we add 3 to get 10, then we add 3 more matchsticks here to get 13, and then we add 3 more here to get 16. If you were struggling with this concept, but just having gone through this first example, that gives you a good idea of what you should do on the second one. You might want to pause the video now and have a go at the second one on your own. Otherwise, please just carry on. So here we can see we start off with 3, and then again we're adding 2 each time just to make an additional triangle. So your next diagram should look like this. And then if we write a sequence of numbers to represent how the number of matchsticks changes, we should have 3, 5, 7, 9, 11, which makes sense because we start with 3 here, and as we've already said, we just add an extra 2 matchsticks each time, so we're adding 2 each time here. Brilliant. Okay, the reason we've started with that is because of our new chapter is all to do with sequences. So today our bronze criteria is to recognise how number sequences are built up. Silver is to be able to generate sequences when given the nth term, and that's always something students worry about, but it just means it's a rule. The rules could look different depending on the sequence, but it is just a rule that you apply. It's nice and straightforward. And then we're going to have a go at just some old exam style questions from previous exam papers, so you can see what these things would look like in an examination form. Okay, so first things first, some of this you will know before because you look at this briefly in Key Stage 3, so it won't all be brand new, but I'll just read through this for you just to remind you. So generally, when we're looking at sequences, we're looking at numbers. Sometimes it can be numbers and letters, and we'll look at that later on. But each number in a sequence is called a term. So the first number is the first term, the second number is the second term, the third number is the third term, and so on. And each term has a specific position in the sequence, so it's the first, the second, the third. And then terms that follow on one from the other are consecutive terms. They come after one another. So if you're counting from 1 to 5, 1, 2, 3, 4, 5, the numbers 1 to 5 are consecutive terms because they follow on. And the rule that shows how to work out which terms come and how they arrive and how the sequence is made, we call that the term-to-term rule. And we're going to look at how that works here. And you might choose at the end of this slide just to maybe copy down what appears, or if you feel confident you might not need to, but it might be a good thing for you to refer back to. So we're going to look at a sequence here. Here are our first 4 terms in the sequence, and they are 2, 5, 8, and 11. Now if we look, we can see to get from 2 to 5, we add 3. Well, let's just check it's the same here. To get from 5 to 8, we add 3, and then we add 3 to get from 8 to 11. So we've got this constant thing, this constant action that we're doing, and we're adding 3 each time. So that is our term-to-term rule. Now that we know that, and we know it's true because we've checked it for all of the terms, we've checked that it's always add 3, we can then work out the next 2 terms. So 11 plus 3 is 14, and 14 plus 3 is 17. Right, let's look at another one here, slightly different. We've gone 3, 6, 12, and 24. Well, you might first go, well, 3 add 3 gets 6, but 6 add 3 doesn't work to get me 12. So what am I actually doing here? Well, if you feel confident with your number work, and you should do, you can probably see that to get from 3 to 6, you times by 2, and to get from 6 to 12, you times by 2, and to get from 12 to 24, you times by 2. So we're doubling the previous term. We're multiplying each term by 2. So therefore we can work out 24 times 2 is 48, and 48 times 2 is 96. Let's look at one more example together. So here we can see this is different to the other two because our numbers are decreasing in value, it's descending, but it's still a sequence, that doesn't matter. So let's have a look. Well, to get from 35 to 28, we subtract 7, And brilliant, to get from 28 to 21, we subtract 7, and we can see it also works here. So we know that our constant term-to-term rule is to subtract 7 from each previous term. So we can do 14, subtract 7, which is 7, and 7 subtract 7 is 0. And remember, sequences can go into negative numbers, so the next one will be -7 and then -14. Just have a look at this last one for me. What about this sequence here? What's happening here? So we've got 1, 10, 100 and 1000. And hopefully you can look at that really, really quickly and see actually what's happening is the term-to-term rule is to multiply by 10 each time, because 1 times 10 is 10, 10 times 10 is 100, and 100 times 10 is 1000. Brilliant. If you feel super confident going forward, you might not want to copy this down, but otherwise if you think it will help you to have this information to look back on, maybe some guidance on how you might set some of your work out later, you might choose to pause the video now and copy down what's on the slide. Right, brilliant. We're going to have a look at another example, because everything on the previous slide you had the same constant. You were doing the same thing each time from term to term, adding 3, subtracting 7, multiplying by 2. Sometimes it can be a little bit different, and we have to think really carefully about what we're doing to get from one term to the next in our sequence. So to get from 1 to 3, to get from 3 to 6, from 6 to 10, and 10 to 15, and you can probably already see you're not going to do the same thing each time. So if we have a look, there's our sequence, and it always helps to write it down. You can see that actually to get from 1 to 3, you add 2. To get from 3 to 6, you add 3. To get from 6 to 10, you add 4. And to get from 10 to 15, you add 5. So it probably now makes sense that, well, I'm adding 2, then 3, then 4, then 5. So I'm just adding an additional bigger number every time I'm going up in ones. So next I'm going to add 6, and I get 21. So then I'll add 7, and I'll get 28. And then if you were to carry on, if you wanted the next term, you would add 8, and you get 36, and so on. So we can see there that sometimes the patterns always aren't obvious. It can help you to write the sequence out, and maybe underneath with some arrows, or not, in a box maybe, just show what's happening each time, and then work out the pattern from there. I'd like you to pause the video, please, and copy down this example. Right, brilliant. What I would like you to do now is to have a look at these 6 sequences. I would like you to write the terms down. So for each of them, you've got either the first 4 or 5 terms. So write those down for me. Identify the term-to-term rule, and then write down the next 2 terms. Please pause the video as you do this. Right, okay. So from the first one, you should be able to see that you're adding 7 each time. And if that's the case, your next 2 terms are 34 and 41. Then if we look at the next one, we can probably see we're adding consecutive numbers. So we're adding 2 here, then 3, then 4. So then we'll be adding 5, and then we'll be adding 6, and we get 18 and 24. So here we can already see this is decreasing. So it's going to be subtracting or dividing. But here we can see we subtract by 1.5 from each previous term to get the next one. Apologies, I think that actually should say 6.5, which means you should have here 5, okay, and 3.5. So from 7, subtract 1.5. Oh no, I am right. I thought that was strange that I might be wrong, because I'm usually right. So it is in fact 5.5, and then we get 4 and 2.5. Perfect. I hate being wrong. Right, the next one we can see we've got 1, 3, 9 and 27. So it's not a constant difference. So there's something else happening here, and hopefully you've noticed that you're multiplying by 3. So you're multiplying each previous term by 3. So 1 times 3 is 3, 3 times 3 is 9, and 9 times 3 is 27. So 27 times 3 is 81, 81 times 3 is 243. Right, let's look at this next one here. So again, not obvious. We're adding 3, we're adding 2, we're adding 5. Doesn't really make sense. Can we spot another pattern here? This isn't one we explicitly looked at. And when you were lower down the school, you might have looked at something called the Fibonacci Sequence. And what that means is, to get each term in the sequence, you add the 2 before. So here, we start with 2 and 5. Now 2 add 5 gets us 7. And then 5 add 7 gets us 12, and then 7 add 12 gets us 19. So for the next term, you do 12 add 19, which is 31, and then you do 19 add 31 is 50, And particularly if you're in 10x4 and 10y4, if you had a look at the wonderful displays I've done in MA2, you'll have noticed there's a whole display on the Fibonacci sequence, so I'm hoping you all got that right. And then here we can see that again our sequence is decreasing, so it's going to be a subtraction, okay, or it's going to be a division. We can probably see it's not a constant subtraction. What we're actually doing is we're dividing by 3 each time, so our next ones are 3 and 1. And please mark your work. If you need to make any corrections or put any things in you weren't quite sure about, please do that now. Excellent. Right, there are some questions for you to have a go at. So question 1 is the standard examples, and then question 2 and 3 are non-standard, but they've actually got diagrams to help you. So read through the questions really, really carefully and have a go at answering them. And please pause the video as you do this. Right, brilliant. The observational lot amongst you will have noticed hints and tips here. So these patterns do not go up by the same value each time, so you need to find another connection. So that was helpful, okay? It gives you an idea of what you've got to do. So hopefully for the first one here, you've got 21 and 34, and then for the second one, you've got 49 and 64, and then for the third one, you've got 47 and 76. And if you're looking at it thinking, oh my goodness, how? We should be able to see that this is another Fibonacci sequence. 1 add 1 is 2, 1 add 2 is 3, 2 add 3 is 5, and 3 add 5 is 8, and so on. So you do 8 add 13 to get 21, and 13 add 21 to get 34. So you've got a Fibonacci sequence. You might have written a sentence. You might have put you add the previous 2 terms to get the next one. You spot on there. Right here, again, we're adding consecutive numbers, but this time it's odd numbers. So you're adding 3, then 5, then 7, then 9, then 11, so you add 13 and then you add 15. And this is where it's probably quite helpful to write the sequence and underneath try and write what's happening each time and see if you notice a pattern, okay? And then again here, 3 and 4 is 7, 4 and 7 is 11, 7 and 11 is 18, and so on. So we should again recognise it's our Fibonacci sequence. Right, brilliant. Let's look at 2 and 3. The first thing I would do is again look for a pattern. You might not have drawn the diagrams, you don't need to if you don't want to. You might have written the numbers out to help you. Here we're adding 2, then we're adding 3, then we're adding 4. So it makes sense to do 10 add 5 is 15, and 15 add 6 is 21, then add 7, then add 8. And these are called triangular numbers, and the diagram shows you why. So if you ever wonder specifically triangular numbers, you're starting at 1 and then you're adding on consecutive numbers each time. Right, brilliant. Let's have a look here. So for question 3, the pattern shows how hexagonal numbers are formed. Hexagonal is important. What is the first number that comes to mind when you hear hexagonal? I'm hoping it's 6. That comes into play shortly. Now it says here, work out the next 3 hexagonal numbers. And you can see why they're called hexagonal numbers, because what's happening each time is they're just adding an outer shell of circles or discs to make the diagram bigger. Let's have a look. We're adding 6, and we're adding 12, and we're adding 18. And some of you will have got this straight away, and some of you think, well, Miss has just said, talked about number 6. I can only see a 6 once. But you'll notice that actually 6, 12, 18, it's adding up the consecutive numbers in the 6 times table. So the next number we add to 37 will be 24, which is 61. Then we add 30 and get 91. Then we add 36 and get 127. If you feel it will help you, you could pause the video now if you wanted to draw those diagrams and maybe get the sequences and really process what's happening there. Right, brilliant. Have a look at these 2 questions for me, and then we're going to look at some further exam questions. Just pause the video as you have a go at these questions. Right, brilliant. Question 9. Look at these 2 sequences. It says you've got sequence 1 here and sequence 2, and it says the first term they have in common is 17. Now we should know that in common means it's got the same, so the first term in common is a 17. Okay, there's nothing before that they both have. What are the next 2 terms that they have in common? Let's just carry the sequences on. We can see here we're adding 3. Let's keep doing that for a little while. Let's draw the next few terms. And here we're adding 4. So let's do that. Let's draw the next few terms. And brilliant, we can see both got a 29 and both got a 41. And if you draw them and you hadn't found the second term, just do the next few terms of each sequence and you'll find it. It's as straightforward as that. Now, this one's interesting because this is one where in an exam you'd have to write your answer. You have to use words, a sentence. And it says, look at these 2 sequences. Will the 2 sequences ever have a term in common. And the important bit is give a reason for your answer. Now you can't just say yes or no. You have to pick one and go with it, but only one of them is right. Now if we have a look, we can see here we're adding 3 each time. Okay? And then here we're adding 3 each time. Now the misconception students make is they say, well, both of the sequences you're adding 3, so of course they'll meet. But not if the starting point isn't the same. If you're adding 3 on each time from 2 and you're adding 3 on each time from 3, because you're always adding the same number and you haven't started from the same point, they will never have a term in common. And that's the ideal sentence. But you might have reworded it slightly. But again, similarly, you could have had a question that started at 4 and 5, and then you add 4 and you add 5. Will they ever meet? Well, no. Right, lovely. Practice exam question. 4 marks. Give yourself 4 minutes if you need it. See if you can answer them. So we've got 2 parts here and then an extra 2 parts here for the higher level learning. Pause the video please as you have a go at these questions. Brilliant, we'll go through this one together. Here are the first 4 terms of a number sequence. Write down the next term. So first let's work out what's happening. So we're adding 4 each time. So 23 add 4 is 27. Big tick if you've got that one right in your red pen, which I'm sure you've got. Explain how you found your answer. You might have just put add 4 each time. I've gone a bit long-winded. The constant is 4, so what you're adding each time is 4, so you add 4 to each term. But anything that says adding 4 each time, easy, got it. Now this is our higher level thinking. So lots of you need to be looking at these sorts of things quite often to answer the more complex questions. So the 100th term of the sequence, that's this sequence, is 407. Find the 99th term and explain how you found it. So we're trying to find the term before. Now if to move up through the term, you'd know to get from the 99th to the 100th term, you'd add 4. So what would you do if you're working backwards? Well, you'd subtract 4. So the 99th term would be 403. We know that's right because the rule that we've learnt from here is plus 4, and 403 plus 4 is 407. But to work backwards, instead of adding 4, you've subtracted 4 to move backwards through the terms. Okay? Perfect. Right, now have a go at this one for me, just 2 marks. Pause the video as you do this. Right, brilliant. We can see here there isn't a constant change in the sense that it's not an addition or subtraction, but there is something else constant that's happening, and you maybe will struggle to notice it here, but you might notice it here. And you should have the next term as 16, and if you have, you've noticed the term-to-term rule, and you'll have noticed that you're dividing each previous term by 2 to get the next term. So if you ask for the next term after this, well, 16 divided by 2 is 8, the next one will be 8 divided by 2, which is 4, and so on and so forth. Brilliant. Right, if you could now have a look at this, read these questions carefully, because with the questions we've done so far, you're in the habit of saying, this is the next term, this is why. Look, it's a different sort of question here. So please read it carefully and pause the video as you have a go. Right, good. So here are the first 4 terms in a number sequence. We've got 132, 124, 116 and 108. And you've been asked to write down the next 2 names in this the next 2 numbers or the next 2 terms in the sequence. And you've probably worked out that what you're doing each time here is you're subtracting 8. So we'll keep subtracting 8, or we'll do it 2 more times. 108 take away 8 is 100, and 100 take away 8 is 92. Now, it says here 11 cannot be a term in this sequence. Explain why. Now, it's telling you it can't. So like I say to my groups all the time, don't say it can. You've been told it can't. What do you notice about all of the numbers in the sequence? Well, for starters, they're all even. And you're also taking away 8 each time. And an even number, subtract another even number, gets you an even number. So the answer is subtracting 8 from an even number will never result in an odd number. 11 is an odd number. And that's it. Right, brilliant. A bit more challenging. So I said at the start of the lesson that we'd have a look at a couple of sequences that have got numbers and letters in, so a bit of algebra. If you feel confident, I'd like you to pause the video at this point and see if you can work it out. Now this is 2 marks, which tells you there are probably 2 parts to the answer. You can see there's 2 parts to each term, so you get a mark per correct one. So if you feel confident, pause the video and have a go. And if you don't, I'll give you a bit of guidance with the next bit. Right, if you need guidance, what we're going to do is we're going to break down this sequence. So we're just going to look at our A's first. So 2A, 3A, 4A. What's happening each time? Can you find the next part of the sequence? Hopefully you feel more confident now and you can pause the video as you work through the rest of it. Good, so we can see here we're adding one extra A each time. So the next one would be 5A. Let's look at our B's, that's the next part of our sequence. So B, which on its own is 1B. So 1B to 5B is you add 4B, and then you add 4B again. So we'll add 4B again, and we get plus 13B. It's a really good one that I'd maybe like you to copy down. You might even like to put plus 1A, plus 1A, plus 4B, plus 4B, because it's really good to refer back to, particularly for these higher level questions. Right, lovely. Okay, next part of the lesson, we're storming through. Sort of follow what we're doing here. So what we've done at the moment is we've just found the next terms in sequence. We've found the term to term rule and we've added to sequences. Brilliant. And now we're going to look at what happens when we're given an nth term rule, and that's the thing that students hate. But the nth term rule, this thing here, is just an example of this, and it's just basic algebra and basic substitution. So instead of being given a sequence already, you're asked to produce the sequence based on this rule. And that's the rule for this particular sequences. The rule's going to be different, okay? So a sequence is formed by the rule 3n plus 1. Now you're told here n is 1, 2, 3, 4, 5, 6 and so on. That's the position of each term in the sequence. So n is 1, then it's 2, then it's 3, then it's 4, and then it's 5. That's brilliant, because we know what n is. We can substitute n into our term to term rule. Now some of you will be able to do that just from looking at you go, brilliant, n is 1, 3 times 1 is 3 plus 1 is 4, got the first term in the sequence. But if you struggle, sometimes using a table will help you visualise it, particularly in the beginning. So I'm going to do the 3n part first, which we should know is 3 multiplied by n, and n is these numbers here, and then we'll add 1 and we'll get our sequence. So let's do 3n first. So 3n, n is 1, 3 times 1 is 3. 3 times n, well this time n is 2, we can see it's labelled, 3 times 2 is 6, then n is 3, 3 times 3 is 9, 4 times 3 is 12, and 3 times 5 is 15. But that's not our finished sequence, because we've only done this part of it. Now I've got to add 1 to all of the answers here. So our actual sequence is there. We've created the sequence, we've written the first 5 terms for the sequence, 3n plus 1. I'm going to show you another example, and then after that you can pause the video and copy down what we've done. So this one's slightly different. We've still got an n value perfect, but this time it's a subtract 2. And again, n is going to be 1, 2, 3, 4 and 5. Always assume it is 1, 2, 3, 4 and 5 consecutive numbers, unless you're told otherwise, which is very rare. Okay, but again, some of you will go, brilliant, n is 1, 4 times 1 is 4, take away 2 is 2, and you'll be able to do it. But again, we're going to look at it with a table to break it down. So we'll do the 4n part first, which we know means 4 multiplied by n, whatever n is, which is here. And then we're going to subtract 2. So here, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. So we're almost there. We've now got to subtract 2 from each of the answers we've got above, and we get 2, 6, 10, 14 and 18. Now the eagle-eyed amongst you might have noticed that when you look at the sequences at the bottom, the final sequences, you'll notice there's a constant difference, or there's a constant term-to-term rule. Add 3, add 3, add 3, add 3. That's going to link in later that we've got a 3 here. Add 4, add 4, add 4, add 4, and we've got a 4 in here. And in a couple of lessons time when we look at finding the nth term rule, that's really important. So if you've spotted that now, really well done. Right, I'd like to pause the video now and just copy down these 2 examples. You might use the tables, you might not. You might just write that and then write the sequence. Okay, but I need you to do what helps you. Please pause the video as you do this. Perfect. Right, lots of practice questions here. I've put an example table up for the second one. Okay, if you need help. It says assume n is 1, 2, 3, 4 and 5, as we had in these practice questions. Don't panic when you get a question like this. It just means you'll only have one row here and it'll be 3n. Don't panic here when it's n n will just be 1, then 2, then 3, then 4, then 5. It's just substitution into algebra. Okay, so please pause the video as you find the first 5 terms for each of these sequences. Right, brilliant. If you can make sure you mark in your lovely Manchester United red pen as we go through these. So 3n first. What are the first 5 terms? Well, it's 3, 6, 9, 12 and 15. Because remember, n is 1, 3 times 1 is 3, then it's 2, 3 times 2 is 6, then it's 3, 3 times 3 is 9, 4, 3 times 4 is 12, and 5, 3 times 5 is 15. Perfect. For the next one, 6, 10, 14, 18, 22. Then 7, 9, 11, 13, 15. And just check, 2 times 1 is 2, plus 5 is 7, 2 times 2 is 4, plus 5 is 9. So we're getting it right here. Then we've got 8, 13, 18, 23 and 28. And this one here, remember, if n is 1, 1 plus 2 is 3. If n is 2, 2 plus 2 is 4. If n is 3, 3 plus 2 is 5, and so on. And then we've got 3, 7, 11, 15 and 19. And then we've got G and H, and then this one here. So 1 subtract 7 is negative 6. 2 subtract 7, negative 5. 3 subtract 7, negative 4, and so on. If you've made lots of errors, please go back through and do them again. I know you can see the answers, but please maybe use the tables, do the stepped working out and see if you then get to those correct answers. If you still don't, please get in touch with me or your teacher, your regular maths teacher, and we can give you a bit more guidance. Right, lovely. We're going to jump straight onto our goal criteria now, and this idea of applying to sort of exam questions, but also questions with fractions in. Fractions is always something that makes students panic, and there's no need, because all that's happening is you've just got too many rules here, but the n is constant, the n is the same. Now, if you feel quite confident, you want to challenge yourself to see what you can do, go straight in with this question. You might want to draw a table, you might not. Your answers will most likely be fractions, okay, so expect that. Don't worry if they are. And pause the video and have a go. If you feel less confident, don't pause the video, and I'll put something up to show you. Right, brilliant. Either you're going through the answer or you want a bit more guidance. Here's a table to help you out. If you now feel confident, if you're a bit unsure before, to go through, you can pause the video and work through. If you feel less confident, I'm going to show you something else to help you. So here's our first one. If n is 1, we just substitute 1 into our fraction wherever n was. Now 1 take away 1 is 0, and 1 add 1 is 2. Let's end it with 0 over 2. Hopefully you now get the gist of what you're doing. So when n is 2, well, 2 take away 1 is 1, and 2 add 1 is 3. So it's 1 over 3. If you now feel confident, I would like you to pause the video, work through the other 3 terms. Right, brilliant. Then we've got n is 3. Well, 3 subtract 1. The top here is 2, and 3 plus 1 is 4. And then we've got here, n is 4 this time. So 4 subtract 1 is 3, and 4 plus 1 is 5. And then we've got n as 5. 5 subtract 1 is 4, and 5 add 1 is 6. Done. That's absolutely fine. Because you're not asked to simplify anything. But some of you will be looking at that and saying, Miss or Sir, always say simplify fractions if you can. If you've not been asked to, it doesn't matter. You've done the right thing. If that's how you answered it, it's perfect. But we know that if you are asked to simplify, what could we simplify with these fractions here? And there are actually 3. Have a think, see if you know which 3 they are. Or maybe which ones you know you can't simplify and then use process of elimination. Just have a quick think about it. Okay, good. So the 3 we can simplify are this one here, 0 over 2, 2 quarters, and 4 sixths. So 0 over 2 is just the same as 0. Okay, so we have to simplify a fraction that's a 0 over a denominator of 0. And then 2 quarters, we should know we can divide the numerator and the denominator by 2. And we get a half, it's equivalent to a half. And then we can divide by 2 and get 2/3. Because you've not been asked to do that, you don't have to worry about doing it. But if you ever are, that's what you need to do. So always read the question carefully, have a quick look. Right, to do or not to do. If you want some additional challenge, so top level 5 questions, you can work through the next 2 slides, okay? If you feel like what you've done is challenging enough and you feel like approaching this work is maybe a bit too much for you at the moment, particularly without your teacher in front of you, please just skip the next 2 slides, okay? It's not a problem. You're welcome to do that. Just zoom through the video unless you want to hear my voice, that's fine as well. So if you're working through this, have a look at question 6, read it really carefully. We know that with these nth term rules, because that's all that is, that's just a fancy nth term rule. We're used to seeing things like 3n plus 1 or n take away 6. It's just a fancy version, okay? See if you can apply that to find the first 5 terms of the sequence. And there's a bit of guidance here, look. It tells you when n is 1, you just substitute 1 in for n, and then when n is 2, you substitute 2 in for n. I think I've repeated it down here like a dipstick, so it's a bit clearer. See if you can now find the next 3 terms as well, and then think about where have you met this before in this lesson. Please pause the video as you do this if you want to do it, otherwise zoom through. Brilliant. Okay, so we've hopefully got 1, 3, 6, 10, 15, 21, 28, because we should know if we put 3 in for all of these, okay, we get 3 plus 1 is 4, 3 times 4 is 12, and half of 12 is 6. That's where it comes from. Where have we seen this before? Add 2, add 3, add 4, add 5, add 6, add 7. I'm hoping you now recognise it as our triangular numbers that we looked at much earlier. It'd be expected that you recognise that. If that sequence was to come up, you would just know, because it starts at 1, it's adding up consecutive numbers from 2, you recognise it's triangular. Right, and the last one, so super challenge. So again, if you didn't do the slide before, probably don't attempt this one yet. That will come later, don't worry, we'll have to look at these things again. Otherwise, have a good go, have a read of this question first, and I'll read through it with you, and then pause the video, see if you can answer it. So it says the nth term of a sequence is 3n plus 7, so the rule of one sequence. The nth term, or the rule of another sequence, is 4n, subtract 2. These two sequences have several terms in common, but only one term that is common and has the same position. So it might be the third term in the sequence is the third term for both of them, and it's the same value, okay? Without writing out the sequences, show how you can tell using the expressions for the nth term that it is the 9th term. So you're told it's the 9th term. How can you prove it without writing out the sequences? Pause the video and have a go. Good. If you're struggling, I'm going to pop the first stage up on the board that you should have done there. That's something you've seen before when we did linear equations. Some of my groups loved them, some of them less so. But remember, I kept saying to you, these things are linked, they come in later on, so it's important we try and get a grasp of them. If you feel confident, please now pause the video and have a go. Excellent. So next stage, we're trying to prove that the nth term, the common term they have in common, is the 9th. So we need to know what n equals. So we can subtract 3n from both sides, and we're left with n subtract 2 is 7, and then we can add that 2 to both sides, and we get n equals 9, and that's what we're after. Now these last two slides, this one and this one, are really, really tricky. So if you've really struggled with them, please don't panic. It's so important that if you got all of the things before, just applying the rule to write a sequence and working out what the rules were, if you can do that, that's really good news, okay? But it's important we put these more challenging questions on just for people that want to have a go at them. Right, brilliant. Here he is today. We've got the Hulk. I'll try and make it different every time. So lesson completed, just one PowerPoint this week. Just a reminder, make sure you've done the online test also set for this week, and it was on last chapter's worth of work. There's a link for it on the weekly guidance sheet on the college website. If you can't find it, please let me know. And regarding the online test, as the Hulk would say, you'll smash it. Brilliant. I've enjoyed it. And I will hear you, or you'll hear me again next week. Very well done.